All right, you guys, so we're going to be getting into a lesson today where we're going to start using our quadratic equations to model real life situations. I'm calling it modeling with standard form. I do want to address, yesterday you had a Desmos activity where you were practicing graphing and you were supposed to check homework solutions, and I forgot to post them, and then by the time I was made aware that I had forgotten, I wasn't able to post them. So you are hopefully able to check your solutions today. That hopefully was what you started with, and that's your solutions to Monday night's worksheet. And that's going to be useful because now we're going to start using those standard form equations. So any questions that you have, you can refer back to the work that I'm showing on that worksheet number 1. And of course, we're going to review the stuff when I come back. But yeah, hopefully you're starting to understand certain things about a parabola based on the equation that you have of the quadratic equation. So we're going to start using those now to model real life. And so a parabola and the equation of a parabola can be used to model a lot of things in real life. And the most common of that is things that form parabolic motion. So we call this parabolic motion when something forms a parabola. And anything affected by gravity that you throw, a projectile is what we would call that, would be something that would form a parabola. So if you throw a ball up into the air, it's going to follow the path of a parabola, and we could model it. And you saw that when we were doing the Desmos having to do with basketball, and how your parabolas, hopefully you did better with your guessing of when the basketball would go in the hoop based on if you were using a parabola to model it. So I am going to just give a little notes here on what parts of a parabola might be important if we're trying to answer questions about parabolic motion or anything that's modeled by a quadratic equation. So I've drawn a little bit of a sketch here of a parabola, or maybe part of a parabola, and just think about anything that could model. So if you were just thinking you had to write a story about this parabola, what might it be about? And my assumption is most of you would say something like, oh, maybe it's a ball. I already said this, but maybe there's like a ball that's being tossed up into the air and then landing on the ground. That would be a common one. So things that you might be asked about that, I just want to kind of talk about. So what we typically will do when when we're dealing with parabolic motion, a lot of times we will be talking about height over time. So our function now, the x and the y, they're going to represent something. And knowing what they represent is going to be the first task of any word problem that you're dealing with. So I've just gone ahead and drawn an x-axis and a y-axis. So a common situation is we oftentimes would look at the path over the height over time. So on this one, just jotting down some notes. These notes are going to kind of serve as a guide for you if you're talking about a situation where we're modeling height over time. So on this one, my y-axis represents the height of something. We could say maybe it's a ball being tossed. Oops, I should probably put an arrow there. So height. We might call it h. So if we're talking about something specific, we might use a different variable than y. Sorry, this is the y-axis here, is representing height. And the x-axis is representing time. And maybe your x-axis doesn't represent time. Maybe it represents actual distance. So maybe we talk about height over horizontal distance traveled. But typically your x-axis would represent time. So there's going to be some important parts of the parabola that we've already learned how to find. So we've talked about how to find the y-intercept from standard form. It's one of the easiest things to find, the y-intercept. What might the y-intercept represent in a real-life situation? So let's go with the ball analogy. Somebody here is throwing a ball. That's partly why I didn't throw an entire parabola. So in this situation, if the y-axis, if the parabola hits the y-axis at a certain point, that would be the point 0, h, if we're using h to stand for as our y. What might that h value represent in a real-life situation? So the location of this y-intercept, what would it represent? Well, this h value would represent the initial value or initial height or starting height of the object. So maybe it represents like the height of the person that threw the ball, or where the ball was thrown from, or if it's a cannon, maybe like what was the height of the cannon on a castle wall or something like that. So the y-axis would represent initial value, initial height in this situation. Now, another important point we've talked about and learned how to find on a standard form parabola is the vertex. So we have the vertex as an important point. Now, in this graph, the vertex would have a time. Its x-axis would represent time, and its y-axis would represent height. So I try to stick with the variables that I'm working with. So in this case, we're talking about height and time. And what would that t, if we were to find the x coordinate of the vertex? Actually, I'm going to go ahead and just leave that as x and the y so we don't get confused between coordinates. So if this is an x comma y coordinate, but we know that x represents time, what would that x coordinate of the vertex represent in real life? It would represent the time that it takes to get to that highest point. So it would represent the time when the object reaches its highest point, or the time that it takes before it starts to fall back down. Whereas the y-coordinate of the vertex, what would that represent? Well, the y-axis in this situation represents height, so that would be the height that it reaches at that time. And those are questions you might be asked, like what is the highest point that what's the maximum height that this ball is going to reach? Well, in that case, you would want to find the y coordinate of the vertex. Whereas I might ask you, at what point in the ball's path, after how much time is the ball going to reach its highest point? Well, then you want the x coordinate of the vertex, or the axis of symmetry is another thing that we could say for that x coordinate. Another important point that we're going to start investigating now are the x-intercepts. Okay, so this is the place where the time, the height is 0. So it's when our y-coordinate is 0. I guess I should change this back. I'm going to change that to, I want to stay consistent with the variables that I'm using. So I'm using t to stand for time and h to stand for height. So that's what my x and my y are. So for the x coordinate, that's where my y coordinate is 0. So what would the x coordinate represent in a real life situation? It would represent the time, because again, this is a time, x is time, until the object reaches the ground. Or you could say the time that the object is traveling in the air. And that's a question someone might ask of you too, like how long until the ball hits the ground? Something like that. Those are some of the things you could be asked for, and I'm pointing to the thing that you would want to find. And some of these things we already know how to find. The x-coordinate, x-intercept, we're going to talk about how we would find that because we actually have the skills for that. But yeah, so those are some things that are good to you can refer back to this graphic for, like, okay, if I was asked for this is what I want to find, the y-coordinate of the vertex that was very poorly circled. If I am asked for this, then what I want to find is the x-coordinate of the vertex, which we know how to find. All right, let's do an example. So you can write what you think is important. You don't have to write the whole thing. This video is going to be posted, so if you ever want to refer back to it, you could say 8.2.3 notes, example 1. But we're going to be looking at a diver who's standing on a platform above a pool. And she jumps from the platform. She jumps from the platform into the pool. I should say pool. And it's modeled by this equation, h of t. So this is written in our function notation, and so we're using t instead of x. And that's a good thing, because now we know what x actually stands for. But our t here is our x, and our y is an h for height, and it's written in function notation. So like what this means is height over time, like height based on however much time. The function notation we're going to have to probably review a little bit. So they're saying where h of t represents her height in feet, and t represents time in seconds. All right, the first thing I want you to do anytime you're doing a word problem is I want you to sketch the situation. In this context, the sketch is going to be so important for helping you understand what you want to find to answer questions. Notice I haven't asked a question yet. Let's make a sketch of what we know. Now, when I make a sketch, I mean basic sketch. We might add to our sketch, but right now, what do we know about this parabola based on its equation? That's what I want to put on this sketch. That's it. So first thing, we know we have a parabola because it's quadratic. Do you know which direction this parabola opens? Do you know which direction this parabola opens? That would come from whether its a value is positive or negative. So we're looking at a negative a value. So it's going to be opening down. And what else do we know? Based on the equation alone, without doing any work, we know we have a y-intercept of 40. That c value is our y-intercept. So in terms of a sketch, all I would be looking for is labels for what our x and y axis represent. And note that I am just doing a quadrant 1 graph. I'm going to say that's just h. So we have a t axis and a height axis. And I'm just doing quadrant 1 because we're modeling time, so time is never going to be negative. And because of what I'm talking about, a diver standing on a platform above a pool, that's going to be positive, at least until she goes into the water, but I think we're just pretty much modeling her jump. Now, we have talked about the fact that my parabola is not going to look like that. It's not going to be symmetrical. Like, I know my maximum point is not going to be here because we've talked about how if we have a b value, then it means we don't have the y-axis it's not centered around the y-axis. So I'm going to just draw my sketch like this, where I have a diver jumping up and then back down. And I guess I could take more space up, so I'll just make that a little bigger, something like that. That's all I know. I know the parabola is opening down, and I know that it has a y-intercept of 40. And so what I could label here so far is that this is at 40 feet right there. That's it. That's all I know. But that's going to help me picture things as I start to ask questions, and here's going to be our first question. After how much time, how long will it take to hit the water? How long will it take to hit the water? Now, so we could refer back to the reference on the previous page, or we can look at our sketch to see, what makes sense? If this is height, when would it be hitting the water if the h represents the height above the pool? And that would be here. This would be the point right there where the diver's hitting the water. We're assuming the x-axis here would represent water because that would represent 0 height. Right? So we are looking for, in this case, we want to find the x-intercept. Right there. Okay, so how would we find x-intercept? We've practiced this. We've practiced for this. If we want to find the x-intercept, then we're looking for, literally, when will the height be 0, right? That's what we talked about. This is a place where the height is 0. And we're trying to figure out when that is. And so we want to set our height equal to 0. We're going to do this a lot. If we want a particular height, then we plug that number in for that thing. So we're going to go ahead and take our function and replace the variable that we know we want it to be. So in this case, we want to know when is the height going to be 0, aka when will the person hit the ground, or in this case, the water. And then we will solve for the time that it takes for that. So this is how we're going to find the x-intercept. Set h equal to 0. And now we're pulling back from last unit. So how do we solve a quadratic equation? Many different options open to you. Quadratic formula, you can factor, you can do completing the square. So what do you think I would do first in this equation? You can think about that. And I'm going to go ahead and do it. I'm going to start by dividing both sides by -8 because I'm seeing that common factor jumping out at me. So I'm dividing by -8 so that I don't have that negative in front. So that would leave me with t squared minus 4t minus 5. And then I'm going to try to factor. That's how I always want to solve if I can. So I'm going to get t and t, and 5 times 1 makes 5. And I want to make -4, so I'm going to want my 5 to be negative, right, so that I can get -4. Right, so it's going to add up to -4t with the inner and the outer. And so then I'm going to solve for t. And again, why did I plug 0 in where I plugged it in? Well, that's because that's what I wanted to find. I wanted the height to be 0, and I wanted to find the time that corresponded to that height being 0. Now, I got two answers here. I got t is -1 and t is 5. Which do you think makes sense in terms of answering this question? How long will it take the diver to hit the water? Keep in mind that time is in seconds. T represents a time in seconds. And so the answer here that makes sense would be the positive one. So I'm going to go with this solution, and my answer would be 5 seconds. So I've found the location of this x-intercept is 5. And now I can add that to my picture just to get a little bit more sense of what's going on in this situation. Now, what is the -1? What does that represent? Well, it doesn't represent anything in real life because there is no negative time. We're not going back in time. But if I were to extend my graph, -1 is where this function would hit the x-axis over here, right? A parabola is always going to have two x-intercepts because it's going to hit the x-axis in two places because it's symmetrical. It's just that point doesn't really mean anything in real life because the diver started up here. Hopefully that makes sense. Okay, so that's one question. Let's see what else. What else could we ask? Maybe you would be asked for what is the maximum height reached by the diver? Okay, so what part of my parabola would I want to find if that question was asked? So I look at my picture and, well, what is the maximum height reached? Well, that's going to definitely have to do with this point here, the vertex. But what part of the vertex do I want? Do I want just the x-coordinate of it? Do I just want to know where the axis of symmetry is? Or do I want to know the y-coordinate of it right here? So which of these do I want? Because if I just want the x-coordinate, then I only have so much work to do. If I want the y-coordinate, we might have more to do. So it's going to have to do with the vertex. So let's go ahead and start by, the only way to find the vertex is to start by finding the axis of symmetry. So I would always start with x equals, and in this case it's really t, because that's what x is representing as time, -b over 2a, -2a. So my b, I'm working with this function, remember, my b is 32, and my a is -8. So I've got -32 over -16, which is 2. Remember, this is x, so this is finding that x value of the axis of symmetry, but in this case, my x-axis is time, so that's why I'm labeling it as a t. So what I've just found there is the location of my axis of symmetry. Is that the answer to this question, though? What is the maximum height reached by the diver? No, because that's just the x-coordinate. That's the time that it takes to reach that point. But when I'm looking for the maximum height, I want the h, which in this case is my y coordinate. So what would I do? Now that I've found the x coordinate, I'm going to plug it in. I'm going to use the function notation to represent this. So I'm going to find the height when t is 2. So this is just the notation for what I'm doing over here on the right side of my equation as I'm plugging in 2 for t. I know it's been a while since we used function notation, but this is why we have it, is to label the work that we are doing. I'm finding h of 2, or the height when t is 2. And so the work that I'm actually doing is over on the right side, and this is just a label for it. So what I just found there is h of 2 equals 72. What that means is the height after 2 seconds is 72. So I've just found the y coordinate of that vertex, which is what I want to know. I want to know what is that height there. So I could say 72 feet. Okay, I want to do one last question. It's just so we cover all our bases. After how many seconds is the diver 64 feet above the water? After how many seconds is the diver 64 feet above the water? Let's refer back to our picture to pick what's being asked. So I have a height axis, I have a time axis, and the question is how many seconds is the diver 64 feet above the water? Well, where would 64 fall in this picture? Somewhere in here. So we're trying to find when is the diver at 64 feet. It's going to be somewhere in there. So we are looking for two answers because I'm going to hit 64 on the up and on the down. But how do I find that? That's not a special point on my parabola. That's just a point. So sometimes you're going to be asked about just random points within your function. And so what you do there is you just plug in the appropriate number in the appropriate place. So sometimes we'll just plug in things t. So for instance, I might say, how high will the diver be after 5 seconds? Oh, that's not a good one because we already know 5. How high will the diver be after 4 seconds? Well, we could just plug in 4 in for t and we'd get an h out. But in this case, I don't want to know how high, I want to know how many seconds. And what I have is a height. So I have this right here, this is an h, a height. It's not like the maximum height, it's just a height. And so what we can do is plug in 64 in place of height. Similar to what we did in part A. It's just in part A we are looking for when height was 0. And here we're looking for when height is 64 specifically. So we could find the time that it takes for any height just by plugging in that number in for h and then solving. So we are letting h equal 64 and we're going to solve for the time that goes with 64. So how do we go about solving this? Well, I'm going to subtract 64. We want to always get our quadratic equal to 0. And then I'm going to do the same thing I did on the last one, or on part A where I divided, I don't know why I'm dividing by 2. I want to divide by 8, negative 8. The biggest thing I can so that my numbers get smaller. And then I can factor again. And then again, if I couldn't factor, I could always do quadratic formula, but I'm always going to try to factor. And so what am I going to get here? I'm running out of room, so I'm just going to go ahead and say 3 and 1. So I'm setting my factors equal to 0, and I got 2 values. Now, does that make sense to get 2? Yes, because I'm finding the place, so I can even add this in. So now what I'm learning is that at 1 second and at 3 seconds, I'm reaching a height of 64. See that? So that's what I've just learned from my equation solving. So you can see how a function and these equations can actually represent something. So I've found the two places, or the amount of time that it's going to take to hit 64 on the upswing and then again on the downswing. So at 1 and 3 seconds. Be my answer here. Okay, so here are some good examples kind of using the function that you're given to suit your needs, to answer whatever question's being asked. Sometimes you want to find the vertex. Sometimes you want to find the x-coordinate of the vertex. So for instance, if this question B had been how long, instead of what is the maximum height, how long does it take to reach your maximum height, then the 2 would have been the answer instead of the 72. So you have to pay close attention to what are you being asked for, and then find the appropriate thing. And the sketch can really help with that. Okay, so you're going to have a worksheet. Now, I tried really hard to keep this worksheet short to make sure that you do it. So you're doing a few questions only today, and you're just trying to answer the questions that are being asked, and then we'll see how it goes. And I'll be back tomorrow.